All right, so the topic for today's meetup is feature detectors in computer vision, and following the approach that we had last week, in which we actually took one theoretical concept, divided the sub concepts of that particular concept, and actually did some presentations and discussions to understand the concepts deeply. So we'll be following a similar approach today. And the agenda for today is first, I'll be giving an introductory presentation of what we are doing, and then I'll introduce the theme for today, which is feature detectors in computer vision. And then I'll be allocating the topics. Just a minute, I think someone joined. Yeah, so the agenda for today is after the introductory presentation, I'll be introducing the theme for today. And after that, we'll have an allocation of the topics and some time for preparation, which is 30 minutes, like we did last time. And after that, we would have 5 to 7 minute presentations. So ideally, we would have three presentations in total. But let's see how many teams we can form at the end of it. And after that, we would have a feedback session and then introductions and casual networking. So what we are doing here is that we are a learning community of robotics and artificial intelligence, and we are experimenting with new ways of learning so that we can learn more efficiently and also have some fun in the process. The way we learn is that we conduct weekly meetups where we learn from each other. Ideally, one person would be sharing a project, but we also experiment with new formats and ways of learning. And we do monthly research paper discussions. We had a couple of days ago the first research paper discussion. I'll also be uploading the full video recording on YouTube for that of that. And we also have project accountability. So people who are pursuing a project and want to do it in teams or in accountable or have an accountability partner, the meetup is the right platform to discuss it and share your progress. And also you can do so in Discord. So due to some issues, we couldn't do the meetup today in Discord itself. uh, so I'm doing it on Google Meet, but normally you can discuss it on Discord as well. And everything will be free and accessible to every member regardless of experience or background. The normal format for the weekly meetup is that we focus on a case study based learning, a project based learning approach, in which one person volunteers to explain in depth one particular idea or project. For example, one person volunteered to share about time series data in one of the meetups. I also volunteered to share deep learning for bin picking in one of the meetups. And uh, just a minute, I think so. This is like one disadvantage with Google Meets, I guess, because normally people can join easily, but here I have to approve. So yeah. After a problem definition by the volunteer, we would have directly a brainstorming session where everyone proposes his or her unique idea or solution to the problem. And after that, the volunteer actually presents his original solution. So this is a very open minded way of learning, and everyone contributes to the process of solving the problem. And after that, ideally there's also a code walkthrough where the volunteer walks us through the entire code. And another thing, this is just in my this is just an idea right now, is that we could also allocate tasks so that people who want to actually practice the code, they can do it during the week and share it in the next meetup. All right, so these are just templates of how the projects would be presented by a volunteer. So if someone is interested in volunteering, just let me know, and you can access these documents as well on the server itself. All right. So let's start today with today's theme being feature detectors in computer vision. And this is like an overview of the different kinds of major feature detectors that we have in computer vision. The Canny edge detector, Harris edge detector, Shi-Tomasi, Sift Surf, all these things. So the idea for today is, since we had a good response last time, we want to go with the same approach, such that we'd be allocating the topics and everyone can choose one or more topics, and also form teams, and then you'd be given 30 minutes time to prepare a presentation, and then after that we'll have a quick discussion. So these are the topics, but since the overall theme for today is feature detectors, and maybe some of the feature detectors are not mentioned here, and you want to, for example, take up those topics, you can also do that. But the way we'll be forming teams is that one team would be focusing on edge detectors, so this team would be taking up one or more of the feature detectors, one or more of the edge detectors, for example Canny and Harris, so to say. And the blob detectors would be the team B, and they would be choosing from one of the blob detection algorithms, and the corner detectors would likewise be choosing from the corner detector algorithms. And you can choose one or multiple of these algorithms, depending on the size of the team you form. All right. So, as I mentioned, the process is that we'll be forming 3 teams, and 30 minutes of preparation break will be given. And for preparation, you can, of course, refer to the resources in the computer vision channel in the concept library in Discord. But unfortunately, actually, I do not have access to Discord today, so I won't be able to access it. But generally, you can just Google search it, and I think that would be even more efficient uh, to utilize the 30 minutes effectively. And after that, we'll have 5 to 7 minutes presentation by the 3 teams. And the idea is that hopefully at the end of this 1.5 hour session, each of us can actually learn multiple topics, instead of just a few topics. And there are a few feedbacks from the last event. The last event got a really good response, but the time limit was exceeded and it went to around 3 hours. We definitely want to avoid that, and we'd stick with the 1.5 hour time limit. And so we'll be taking note of the presentations, and making sure that they are 5 to 7 minutes uh, long, and not more than that. And the concepts explained by a lot of people, probably also including me, were not fully understood by everyone, because not everyone is of the computer vision background. But the idea is that everyone should be able to understand, and so we should try to explain it as simply as possible, although that is really difficult, but that is what we will be trying to do today. And so another bit of addition today is that we'll be using the Feynman technique for explanation, because Richard Feynman says that the best way to understand something is to try to explain it to a 12-year-old, or a really small kid. And if you can explain it to a person who has no knowledge of a particular field, then you really know the subject. So this is what we'll be trying to do today. Let's see how successful we are at the end of it. So I'll just quickly summarize how we'll go about it. For example, you choose one concept, for example edge detectors, and you choose um Canny edge detectors and Harris edge detector. So you can write the name of one particular concept first. So Canny edge detection, and maybe you have some previous knowledge, so you will write everything you know on a sheet of paper, or on a Word document, or a PPT, whatever you prefer. And right after writing everything you know in simple language, you will include some examples, and you will try to make a presentation such that a person with no experience can actually understand it. Sounds simple, but actually is quite hard, I think. uh, then you can refer to Google or other resources to fill gaps in information, because of course, even if you have some background, you probably can refine your knowledge and understanding as well. And then after that, we can you can do multiple iterations depending on how you progress during the 30-minute durations, and try to make it as simpler as possible. And the goal is not to make this process really complicated. The goal is that uh, everyone should actually understand the concepts shared at the end of it. I think that would be the most efficient use of this time, because if we share some ideas and they are not clearly understood, then yeah, that's not really effective. But let's see, it's another experiment today, so let's see how well we are able to do it. And yeah, that's it from my presentation. If you have any doubts, let's discuss it first, and then we can proceed with the process. Was everything clear? Johnny Boo, was everything clear?
Yeah.
Yeah, it was.
How does it sound like? It's the same thing that we did last time, but we are trying to make the explanation process a bit like formal, organized, and simple.
I guess how do we split teams?
Yeah, so again, like splitting teams would be just like last time. So I think we are lesser than last time, so we can take up lesser topics as well, and probably that means we can understand the topics more deeply as well. So these are the topics. Uh, Maybe you can form teams and select the topics. So like last time, maybe I'll just read out the topics, and you can select the one who would want to volunteer for that topic. You can just say that, yeah, I'm interested in this. So the first one, canny edge detector, or maybe, okay, since we are grouping the topics today, so first let's see how many people are interested in edge detectors. So let's first form the team for edge detectors. So how many people are interested in edge detectors actually? Okay. Martian man, which topic are you interested in? Let's go that way.
Uh, okay. What all topics were there?
Yeah.
Edge detection, then, and I then can edge corner. Yeah, edge detection would be good, but I really don't have any experience
Yeah,
in any
that's
of them.
that's the idea. I mean, I think a lot of people are hesitant because you don't have knowledge about this. To be honest, I also haven't brushed these concepts, so I have to kind of start from scratch myself. But that's the idea, right? Like you can Google it and try to come up with maybe one portion of the explanation or something like that.
Yeah. Okay. Okay. I'll
Yeah.
try my best.
Okay. Okay. So edge detectors you want to choose, right? And anybody else? I think we are already like not enough people to form teams, I guess. So we can just choose like one topic each, and maybe two people can choose one of the topics. So Martian man, I think you are choosing edge detectors, right? And
Yeah. 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 Yeah.
okay, and blob detectors. Virendra, what are you interested in?
In chat, he said he wants to go with the edge detectors.
Okay. Mhm, mhm. Okay, all right, perfect. Got it. All right, and so I think maybe we can just take edge detectors, right?
Yeah, I was thinking I'll be taking fast and Thomas.
Okay, fast and Shitomasi is edge detector, and you also want to take fast, huh?
Yeah.
All right. Okay. So yeah, I think we can write in the chat, and I can also take some other topics. So maybe you can write the topics that you have chosen, and meanwhile I can take probably I can take Laplacian of Gaussian, and maybe also and Harris, I guess. I think I'll take one. I'll take just one. Laplacian of Gaussian is what I'll take now. So Johnny and Martin, you can also write in the chat. Yeah, I just got a message from Martian. He wants to just observe. He doesn't want to participate today. So I think today Virender is taking already edge detectors, right? Which specific edge detector did you mention? Can you also write that, Virender? Right, perfect. Okay, then sounds good. And when you are ready, just let me know, and we can take 30 minutes. I'll start a timer, and after that we can begin with the presentation. And by the way, I think I already shared the presentation as well on Discord. If you have any doubts regarding the format of presentation, maybe I can also walk you through the process once more if you want. What do you guys say? Okay, Virendra says
Yes, yeah, yeah.
okay.
I I think you can start without the presentation. If anyone wants, then they can. I mean, the newcomers, it would be helpful for them.
Yeah, I think Virendra wrote that you can explain the process once more, so I'll just go through it quickly. All right. Yeah. So the whole idea is just to explain it simply, right? So the how you'd begin is you took canny edge detection, so you would write the concept and also write on the sheet of paper what you already know about it. And as you begin writing, you will observe that you there are like gaps in your knowledge, and you can Google it and try to fill those gaps and create an explanation, a very simple explanation that you would probably be explaining to a 12-year-old, for instance. You can also include examples that would make the explanation easier. That's optional, but examples would, I think, make the explanation very practical and easy. And yeah, so and then you can just repeat the process and try to look at your explanation after every iteration and try to make it simpler. And when you are like satisfied that it cannot be made more simpler, then it should be done. But we have another constraint in that we have 30 minutes. So whatever level you can achieve in 30 minutes, I think that should be sufficient. All right. So Virendra, it's clear to you, right? You can write on the chat. Okay, we are starting now. 8:28 it is, and yeah, we can meet after 30 minutes again here. So Johnny joined. So basically we are waiting for Virendra. He needs a few more minutes. So Virendra, whenever you are ready, just let us know. Just write, and then we can start with the presentations.
Okay, I am ready.
Okay, perfect. So do you want to begin with explaining, or should I do it first?
Okay, I will start.
Okay, perfect.
So basically, my topic is canny edge detector, and in this, we have to detect the edges. Means what? How would we define edges? So basically, edges can be differentiated by two high intensity portions of the pixels, where we can differentiate that this was a brighter portion and here is a part differentiating with higher intensity part on the other side. Let's say we have a black image, and at the other side we have a white image. Between them, no, Johnny Boo. I don't. I've not prepared for a PPT.
I thought you are sharing screen. I cannot see.
Okay. Uh, so can I continue?
Yeah, please.
Okay, the edges would be detected like if you have a black image, let's say a cube on a white paper, then the higher intensity portion like black would be given like 1 1 1 1, and the white would give us 0 0 0. So the higher intensity portion means resembling that there is a age between that. So how would we find it uh, in a computer vision? So basically, first we have to take a grayscale image to use a Sobel operator. First, for using a Sobel operator, the image which we have to find the edges, there are a lot many noises, and after taking a Sobel operator we can get a thick thick edges by using a Sobel operator, which is the disadvantage of the Sobel edge detection. Means like there we get really big edges, which I found on the internet, and so that Canny Edge does a job well in that part. Like it first takes a grayscale image, then does we have to do a Gaussian blur, and then with that a part of portion where we get edges, we find the edges by taking a Sobel operator, that is gx and gy, and after that we take a square root of gx square plus gy square, and after that we by taking a tan inverse of gy upon gx, that is Sobel operator in y and Sobel operator in x, we would get the orientation of edges in the image. So after that we have to after we get the orientation, we have to now remove the noise by hysteresis thresholding. In this, this is a two-level thresholding, which we assign two maximas, and we consider only those part which are between those edges. So we get a thin line in between them, and after this, we could get a canny edge image. Uh, so I hope anyone could understand it.
Okay, yeah, that's a step-by-step explanation. But I think it would be a lot more clear if you shared something. It's also okay if you share resources from other people, other PPTs or anything, just to see what do you mean by the Sobel operator, and I think it would be more clear to everyone then. If you can like share, if you can share your screen, the references that you referred, maybe it's a document or anything, but if you share it, I think it would make more sense.
Uh, is my screen visible now?
Yeah, your screen is visible.
So basically, this is means I followed this video of computer file where he talks about the Canny Edge detector. In that, he mentioned that first we use Sobel operator to take it as an input for a Canny Edge detection. Okay, so what is a Sobel operator? In this OpenCV's official site, we have the theory, means what is it all about. So the Sobel operator is nothing but the two higher portions of the intensity. Uh, let's say this black line and this white background. Okay, so here we can differentiate that this is high, means this is black and this is white, and here we have a edge. So by taking the means once we use we find the higher portions by let's say this is 1 1 and this is 0 0, and we get pixels like 1 1 1 1 0 0 0. So that we will multiply with gx, and gx is nothing but in matrix -1 -2 -1 0 0 0 1 2 1. So let's suppose this 1 1 1 1 1 1, this is a whole 3 by 3 matrix, like unity matrix, not an identity matrix. So 1 1 1 1 1 1 1 1 1 would be multiplied with the gx, and gx is nothing but, let's say we had, okay, see, this is, so this is gx matrix, and these are the whole pixels. We can differentiate that here there would be a age, but after multiplying this matrix with this pixels of matrix, we would get the gx and gy. Means we have to first add those and sum all the numbers, and same goes for the gy matrix, which is just the transpose of it. This is just a transpose matrix of it, and this gx and gy would be used in finding the whole g, and we would get gx square plus gy square, and from this we would get a orientation where our age is, means like our age would be like year 90 degree. Okay, so after getting this age, we would take this orientation and apply it to the hysteresis thresholding. Now hysteresis thresholding like means we don't want edges like uh, we sometimes have noise. If I have a, let's say, 2 megapixel image photo, and there are some black and white dots on that, so I don't want that to be considered as an edge. So what I can do is give a thresholding that these are the tiny dots with less number of intensity in grayscale image, let's say between 1 to below 50, 0 to 50, and above 170 to 255. I don't want those values. Only want the values between 50 to 175, and that would be my hysteresis thresholding. Once I get those, I would get the canny age detection, and it would just let's see. This is hysteresis thresholding. This is the max value. This is the mean value. Suppose the grayscale image would be in 0 to 255. For I am considering for an 8-bit image. So 8-bit image like this is 0, 25. This is 175, and this is 255. I don't want to consider these upper values also. I don't want to consider these lower values. I would only consider these values. And after this, I have done, means what was the first step for me? First step was taking a grayscale image, then doing a Gaussian blur, taking Sobel operators, and finding the orientation. After finding the orientation, remove the noise by doing hysteresis thresholding. This mean value, this is max value, and we get a canny edge detector.
Okay, yeah, now it makes more sense. So thanks a lot for the explanation. If
Was
anybody
it
has any questions, you can ask Virendra.
So, Virendra, that was a pretty clear explanation. Uh, Regarding the hysteresis thresholding, so
hmm,
if we have multiple edges, using the thresholding, we can actually filter other noisy edges and fix on the original edge that we consider to be real. Is that right way to think?
sorry, I couldn't understand your point. Means what you want to convey. Means could you please elaborate more on it?
The hysteresis thresholding. Can you explain what does it do?
Okay. Uh, So what happened in the this Sobel operator um, is it like here? Can I use Jamboard? Okay. Okay. Uh, so when I zoom this, means let's say consider this is an image. I know where an edge should be. Okay. Is my screen visible? I am using the Jamboard right now.
Yep.
Yeah.
Okay. So, so what means what I saw that in video. This, if I know where the edge would be right now. Okay. When I zoomed it, then there would be like the intensity of images when this is zoom. Okay. When this part of the portion is zoomed. Okay. When I would get some number of pixels. Okay. Then it is not necessary that all the images would have the values like maximum 255 255 everywhere. Okay. 255 255 255. Okay. And what you can see from this image is like only thin edges are detectable over here. Okay, not a very means like uh, very thick lined edges are not visible, only thin lined edges are there.
Hmm.
Okay, and we just want only that thin lined edges, not want the extra portion. Like we can have the edges over, see a person sitting here, we can have the edges of a person sitting here, we can have the portion. If that would be the case, then this would be like a thick means like thick line moving here and there around. So if I just do if I didn't use the if I didn't use the hysteresis thresholding, then what would happen is my output of an image would be like this is my age. Okay, then my my edge would be like this much thick. Okay, this much thick, but I want my edge now to be like just one line. Okay, means only the center portion of that. When I means when I
Yeah.
see here that extra pixels which are around here and extra pixels which are around here, I don't want that. I just want to get rid of those extra pixels. Then how could I get rid of those extra pixels is by assigning a hysteresis thresholding, which is, let's say I would give a minimum value that are in this portion, in that pixels, only I want 128, means like 128 till uh, 200, and I don't want this surrounding like 0, 2, 3. I don't want these pixels to be considered, and I don't want like this much big edge to be detected. I just want this thin line. So that's where the hysteresis thresholding is used. uh, I think so this is explained in this part as well. This would be much clear. See,
Yeah, I
I
think
can.
that's clear as well. What you
Yep.
explained, it makes
Yeah.
sense.
Okay.
Johnny, was it clear to you, or do you want?
Yeah, it is. Yeah, thanks.
Okay,
Okay.
perfect. Thanks a lot, Virendra, for the really nice explanation, and also for uh, doing these illustrations that I think gave a lot of clarity as well. So
Okay.
thank you. We'll do introductions at the end, so we'll get the chance to get to know you and what your interests and other things are.
Okay.
Basically, yeah,
Thank you, sir.
yeah. So Johnny, do you want to present next?
Sure. I'll be presenting fast Harris as well as Show Tomasi.
Okay. Yeah.
So, sure. Let me share my screen. Do I need to say present now or?
Yeah, yeah. You can present now.
Can you guys see my screen?
Yeah, I can.
Okay. So I'll be presenting fast and then Harris and then Show Tomasi. But in reality, in terms of fast, in terms of feature detectors, first Harris detector were invented and then Show Tomasi and then fast. I am not
Okay.
going chronological order, but
Mm-hmm.
this was made in hurry. So the fast is a synonym for is an acronym for feature from accelerated segment test corner. It's a corner based detector, and the applications would be it's very much used in the feature based SLAM. Uh, so you can reconstruct the entire map using the features, and it can also be used in image stitching. So if you have your phone, if you slide your phone over the entire scene, it just gives you a panoramic view of the image that is actually underneath. It uses feature-based detections, and it could be using fast, but usually nowadays they're using shift. Anyways, so in the background, it was invented by Edward and Tom, and on 2006, so it's recent, uh, and it's very computationally efficient. So the algorithm is as follows. So suppose if you have an image and you take a pixel P and you zoom the pixel, and you'll get a grid of pixels. And we chose P, right? So when you zoom in, the P is this. And then you form, uh, and let's say the P, the dark pixel, let it be an intensity value, let's say IP, and you selected some kind of threshold value. Let us call it as T, and then you draw a 16 pixel white circle around that interest point, and it's called Bresheman circle. When I searched it up, it said it's a midpoint circle algorithm used in computer graphics, uh, as a side fact. And then yeah, and then you'll be searching if there's a n contiguous pixels. N is the parameter that we can choose, but in the paper, author chose n to be 12. So if you have n contiguous pixels that are greater than the current intensity plus some kind of threshold, and less than current intensity minus some kind of threshold. So this is the same fact that Virender was talking about previously. It's basically the difference between the high intensity and low intensity, and that point is called a corner. And that is what this image explains with some math notations. Don't worry if you don't understand the math, but the point is you're finding a pixel with where you have varying intensities left and right.
Is there a reason why we have selected 16 points or
If you there's no reason, it's mostly a trial and error. And also you should also note that if you have a larger circle, then you have the largest window to search for
yeah?
more computation. So I think authors were trying to reduce this circle, and then the best one they found were 16 pixel circles.
Okay, yeah, that makes sense.
Yeah, if you go even like 12 or 11 pixel circle, we might not get neighboring pixels.
Yeah, yeah.
Yeah. So I think they played with some values and then found 16 to be best one. Uh, yeah. So again, comparing each and every pixel in the circle would be expensive, right? So the best way to make quickly decide if this pixel is a corner or not by they usually check 1, 5, 9, and 13. So these corners of a circle, you can say. So if at least 3 of the 4 pixels are not above or below the threshold, then reject P. And if they are, then you can check other points uh, and n contiguous points. They used n to be 12 to be lie in within the threshold, and if they do, then that point is a corner, and that's the point that we're interested in. Yeah. So in image, it will be looking something like this. So it found corners, interesting points, and I didn't cover maximum suppression. Suppression. It's similar to what Virendra was saying about hysteresis. It's like eliminating duplicate points.
Yeah.
It sounds like that, but I have to look it up. Uh, yeah, and then to speed up even further, which I didn't actually include a slide, people are using machine learning techniques to actually train the features and use trees to find out if the point is interesting or not. So coming to Harris Corner, uh, by the way, is everything clear with this algorithm? Did you guys get a basic sense of what
Yeah. Yeah,
past it?
yeah, I think it's fine. So if we can also discuss the doubts after you present all of the detectors.
Yep. Okay. Yeah. Yeah. And for Harris Corner, it's a combination of edge and corner detection. So the background is it was invented by Chris Harris and Mike Stevens in 1988. That was even before I was born. And it's a combination of corner and edge detector. So be aware there'll be so much math, but I'll try to explain the gist of it. Don't worry about the notations. Just uh, focus on the concept. So you have a function of u and v. In pixels, we use u and v, and x and y are the coordinates. And you use some kind of window function, a kernel, to go over the image. And that kernel is usually a rectangular window or a Gaussian window, which actually gives weight to certain pixels. Yes, in CNN, if you're familiar, you'll have a kernel which goes through each image and assigns weights. Similarly,
Yeah.
uh, so you have a shifted intensity and you have a current intensity. Our goal is to maximize this function. So as we know that if a corner, we have a difference in intensity. Assuming that if you maximize the intensity, the shifted intensity will be maximized, and then the current intensity, and hence you find the current point to be a corner. So that's what they try to maximize this function. They did a bunch of math, and then they arrived to this equation. Uh, and then where m is this matrix, I, x, and iy are derivatives, or also known as Sobel filters in the vertical and horizontal axis. Uh, yeah, and then this is a scoring function they used. Uh, Determinant of m minus k trace of m. I have no idea how they arrived, but it will be interesting to look at the math. And so determinant of n can be divided into lambda. This is actually lambda 1 times lambda 2. And trace of m is nothing but lambda 1 plus lambda 2. So these are basically eigenvalues. And with the eigenvalues, once you have the eigenvalues, you're basically done. Now you can actually query to find if that point is a corner or not. So the determinant, if the determinant of the scoring function is small, meaning our eigenvalues are small. So that region is flat region. If our scoring function is negative, less than 0, then our eigenvalues are eigenvalue 1 is greater than eigenvalue 2, or eigenvalue 2 is greater than eigenvalue 1, and that is considered as edge. And finally, if our R value is very, very large, then lambda 1 or lambda 2 are very large, or lambda 1 or lambda 2 similar. And it's a both conditions should be true, meaning that we have a corner. It's interesting to actually graph these eigenvalues and see on an image, but that is the theory for the Harris. And Shi Tomasi is basically the same as Harris, but they improved the scoring function. So it's an updated version, and it was invented by Shi and Tomasi in 1994. And so the theory is, so in Harris we saw this is the scoring function they used, and in this detector they used a scoring function which will minimize the eigenvalues. And so once you have that, then you can query if that scoring function is greater than certain lambda minimum, then that thing is a corner. So for example, if you graph it in lambda 1 minus lambda 2 space, you'll get something like this. So if you query a point that is greater than lambda min and greater than lambda min, then you'll get this green box, and which means it's a corner. And this is very abstract, but yeah, in 1996 and 1994, this math was used to actually calculate the corners and interesting points. I think this is the last slide, but you can ask any questions or let me know if I have to explain anything better.
Yeah, first of all, thanks a lot for explaining these concepts. And you took three concepts, which is already a big challenge to explain. Yeah, but you explained really well. And I think the challenge would be that it is very math intensive, and this is very hard to explain during this limited time as well, right? But I think you managed to give the overall idea of it in a very concise way as well. Uh, and we can discuss like after we are done with the presentations, we can also like have a quick discussion as to the kind of things that we want to discuss, uh, or we want to discuss code for one particular of these feature detectors, or we want to discuss multiple of these concepts. But yeah, that's for the end. But yeah, overall I really like the whole explanation. And if anyone has any questions or feedback, you can just say now.
Can you go to third slide of fast? Yes, algorithm part.
Yeah.
Yes, could you explain this again, means lot? What is uh, I underscore p plus t, and what is this doing? I understand that. How did you means like find the corner that is p in this case? But what are the select a pixel p and let it be intensity I underscore p and the 16 pixels to do. Means if I have any geometry, means like any unsymmetric, means like in unsymmetric corner in my image, then would this circle be applied in that case as well?
You mean like
Means suppose I have a what I can say, that I have a line crossing, means like randomly in an image, and the those intensities are not symmetric, like in this case if you compare the 13, 5, 1 and 9, means how can we take that p as a perfect corner in that case?
This is an example. First of all, it won't be precise because in an image we are discretizing it, so there'll be some kind of uncertainty, and that we have to embrace. And also, this is just for one patch. You'll be applying for the entire image patches, so you'll have multiple interesting points. So they'll all be overlapped.
Okay. And what is this line like? P is a corner if there are set of n contiguous pixels. Means, could you
Oh,
explain this
right.
point again?
When they meant n contiguous pixels, so this is a point P. N contiguous pixels meaning 1, 2, 3. So it should be continuous set of pixels. They should be all connected. At least n 12 pixels. I mean n is 12.
Neighboring pixels, so to
Yeah.
say.
Yep.
Okay, okay, okay. I got it.
Yep. So yeah. So as I said, there'll be overlapping pixels in any geometry. The only limitation that this algorithm has is it won't work in computer generated images because it needs these kind of dark regions and lighter regions. And if you don't have that, it won't work. So sharper images won't work. That's why they apply Gaussian blur and then they detect for corners.
Okay.
Yep.
Okay, perfect. So thanks a lot for the explanation. Now I can share my slide. Is my screen visible?
Yep.
Okay. All right. So yeah, my explanation would not be as detailed, but hopefully it will give a clear picture of what Laplacian of Gaussians is. Yeah. So there might be some typos because I wasn't able to finish the editing of the PPT. But let's start. So Laplacian of Gaussians is a corner and blob detector, and the approach that we are using to detect the corners and blobs is using a second order derivative. Just a moment. I think there might be a mistake here. Oh, okay. Yeah, that's fine. All right. Yeah. So we are using a high pass filters, and by high pass filters, we mean that the sum of all of the terms in a window is equal to zero. So consider the first image. We have 0, 1, 0, 1, minus 4, 1, 0, 1, 0. So if we add up all the intensity values, then it adds to zero. And likewise for the second image, for the third image, and for the fourth image. So the third and the fourth image are essentially the negatives of the first and the second image. So you can see here that the intensity of the first of the middle pixel is actually significantly greater than the other than the neighboring points. So this is a property of the high pass filter, and the Laplacian filter that we will be using, another property of it is that it is sensitive to noise. So how do we actually detect edges using, okay, the confusion that I had was because here it shows Laplacian of Gaussian as a corner detector and a blob detector, but the resources that I saw, it just actually detected edges from that. So yeah, I'll just finish the PPT and then we can discuss what the problem here could be. Yeah. So So there are three steps to essentially finding out the edges. Basically, we have a Gaussian filter, which first, given an image, it smooths it performs the smoothing operation, and how it does it I'll also briefly explain. So once we get a smooth image, then a Laplacian operator is applied onto it, and the edge is enhanced. And then after the edge enhancement, we find the zero crossing, where the Laplacian operator would be crossing along the zero portion, and I think it will be more clear in the next slide. Yeah, so here you can see there are the first three images are Gaussian functions with different sigma values, different variants, and the Laplacian is essentially a second derivative of the Gaussian. So the fourth image is the second derivative of the first image, with sigma value of 1, and the second image has a sigma value of 2, third has a sigma value of 4. But if we do the second derivative of the first image, we find something like this. So you can see there are three peaks. The two are negative, two are in the negative direction, and one is a bigger peak in the positive direction. And if we go back to the first slide, we can kind of see a similar pattern. So if we look at the third image, the middle has the middle pixel has the maximum value, so it has the highest peak, 4 here for instance, and all the neighboring ones have -1 here. Yeah, so this is kind of to say how it translates to the image plane. And how we do a second derivative is that we do it both with respect to the to x and with respect to y, and this is how the formula of it will look like. I think it is clear. The way we express a gradient is using this particular symbol, and the way we express Laplacian or the second derivative is using this delta square, this particular symbol. And there are multiple ways in which we can form Laplacian of Gaussian. So as we see that there are two steps. One is passing it through a Gaussian filter, and after that applying a Laplacian operator onto it. So we can either take first the Gaussian of the image, so G is the Gaussian operator, and I is the image, and a delta square, as we have seen, is the Laplacian operator. So we first do the Gaussian, and then we apply the Laplacian operator. This is one way. And another approach is we take the Gaussian filter, and then we perform delta square of it, apply a Laplacian operator on it, and then use the filter that we get subsequently and apply it on the image. So these are just two ways of doing the same things. So you can see here in the image, we have the peak here 16, and then -2. These are the bottom peaks here, and then we have -1 as a neighboring neighboring pixel. So here, if we can see, if we can compare it with the Gaussian, so in Gaussian we have just one positive peak, and in Laplacian what we have is, since it is a second derivative, we have one bigger peak and two smaller peaks if we project it onto a 2D plane. So this is essentially the same thing, but just showing it in 3D essentially. So I hope this thing makes sense. And the algorithm is such that given an image, we apply Laplacian of Gaussian operator using using either first applying Laplacian to a Gaussian and applying the filter to the image, or either just applying Gaussian to the image and then applying the Laplacian to the image. Any of the two approaches, and then we apply this 2D filter. Yeah, and so there are two ways to do it, and these are equivalent essentially. We use a 2D filter, or we can use 4 1D filters as well. So just essentially the same different ways of doing the same thing. And then we find zero crossings. So by zero crossings, I mean here you can see here in the fourth image where this curve would be intersecting with this x-axis essentially. These are called zero crossings here. and then we find the slope of these zero crossings, and then we apply a threshold to the slope and mark edges basically. So this is how the image would look like essentially after this. So yeah, again I think I have a doubt here. Probably I'll check it and also address it later, because it shows that the Wikipedia list shows that Laplacian of Gaussians is actually a corner detector. Uh, yeah, but here it makes sense that it is an edge detector, or maybe I understood it wrongly. But that's what I have to explain. Yeah, if you have questions, we can address that, and we can also discuss the confusion that I have.
It's a very concise presentation. As a fun fact, in Shift, actually, in the back end, Laplacian of Gaussians are being used in Shift to on a multiple. They use a pyramid, and then for each pyramid they use Laplacian of Gaussians. So I wonder if we directly use Laplacians of Gaussians onto an image, or is it a tool will be used along with some kind of a detector?
So the references that I used, they show that it is also used directly as an edge detector. But again, then this is where my confusion comes in, uh, because yeah, so here you can see like zero crossings denote the edge location, right? So I think it is directly used in to detect edges as well. I'm not sure why the reference actually mentioned that it's for corner and blob detection as well. Maybe I missed some of the things there. Yeah, but I think it is directly used as well, apart from as a step in SIFT, I think.
Nice, but it's sensitive to noise, so that would be a limitation, I guess.
Yeah. I mean, yeah, I couldn't prepare a more detailed presentation myself as well. Uh, but was this thing clear how Gaussian is applied actually? And the three steps, I think, did this make sense?
Yeah, they were pretty clear.
Okay. Okay, yeah. This particular doubt, I think I'll check it and we can discuss it in the Discord server itself about Laplacian of Gaussians as well. So, do we have any other questions as well regarding this? Okay. If not, then we can just yeah finish with the presentations and begin with the introduction. So I think Virendra is the one who is new in today's meeting. So maybe you can introduce yourself a bit. Where are you from? What are your interests? And how did you come to know about this particular meetup?
So hello, I am Virendra's Awad. Basically, I am from India, means studying in MIT Academy of Engineering, Pune. I am pursuing electronics and telecommunication engineering, third year undergrad, and I came to know about this from a LinkedIn post. Like sharing, we would be having a community where we all together would share their ideas, and that thought found me interesting.
Okay.
So my basic interest in I want to pursue in robotics. So I keep reading means the stuff related to robotics, which lie in that particular domain. Um, So those are my interests. Like computer vision was one of the part.
Okay, great. Yeah, nice to have you here. And do you plan to do your masters later in robotics as well?
Yes, I'm planning. But means now I'm in just of means like thought process whether what to do next. Means I'm just focusing on present now. But your suggestions would be appreciated.
Yeah, sure. So I think you are at the right place there in the actually in our server the majority of the people are robotics master students here in Germany. Many are from RWTH Aachen and many are also from uh, TUM and other universities as well. And also we have experienced people from all across the world from US and other places as well who are already working in robotics. So I think you will get to know about other people's experiences and how you can probably choose the right course for you or like the right steps to take. Also, if you are like doing your own projects, you can find accountability partners, and with them you can do these projects so that you can get some guidance, uh, so to say, and probably that might help you. Are you doing some projects on your own currently as well?
Yes, currently I'm doing ROS. I can show my recent work I am working on. It is related to mobile robotics only. So basically, a few days. Yes. Is my screen visible current?
Yeah, now it's visible.
Like I have opened the terminal.
Yes, it's visible.
So basically, I have started with ROS. Means 7 or 8 months ago. It's, I kept tinkering with this a lot. I've made a lot of mistakes, and I covered those. And I made this URDF, and I'm just like in the process of I just use this teleop node which
Yeah.
is free, is freely available, but now means my main aim is to move this bot autonomously, means the node which I have added a plugin of camera also, but now main problem I am facing is how could I move it, means like through my equations. I have figured out this those equations for the omnibuild holonomic bot. Now I have to put in that node along with a means like computer vision algorithms, like this is the fixed distance to be maintained so that this can be a follow me bot, and that simulation I would further translate into an hardware and do that into a real bot. So that's my basic aim. I don't know why it is taking a lot of time. I would like close all the extra tabs.
Yeah, so where are you? So you are starting with ROS, right? So which resources are you referring to?
So basically, I follow, or I don't follow any fixed resources. I just go by topics
Yeah,
and
yeah.
find out multiple.
Hmm.
So mostly I found that means one channel, Pranshu Tople, he's from India only. Uh, he made us go through this tutorial of URDF. And other thing I means my friend purchased a Udemy account, so from there I learned basics of ROS
Yeah,
and
that's
other
great.
things.
Yeah, you can also refer to ROS Construct Sim. I think they have really good
The
tutorials.
constructism on YouTube.
Yeah, you might have seen it. If you had errors, I think you would, yeah, see some posts regarding that by them as well. And also, there's one
Yes.
YouTube course by ETH Zurich. I think they have created a playlist for ROS for beginners. I think that would also be beneficial to you.
Uh, could
Really
you
good.
just
This, I guess ETH Zurich one. I did lately, and it is really helpful. So for the beginners,
You're doing it right now, right? Yeah.
I did.
Okay. Okay.
Yeah.
Yeah, ETH
Great.
Zurich is actually also, I think, from for beginners it is good, but it also, if you go further, I think its level increases after every, I think, exercise or so, right?
Yeah, and it's mainly focused on robotic arm. So not like it's particularly about that.
I think it's also about mobile robot. I think they have taken Hector robot as example as well, right? Probably.
Ah,
In the beginning,
yeah.
I think, yeah, I did a few once in the beginning, but I left in between. Yeah.
Yeah, there was a small part. Yeah, there's a part as well. Yeah.
Okay. Yeah. But you
So
can recommend
basically,
this as well, right? This is good.
I've figured out this till now. Means you can see the images over here. Means whether suppose I move this, this could be seen moving over here, but like this is now not coded anymore. So basically, you have you guys have worked with ROS, right?
Yeah.
So means like your suggestions would be appreciated. That what should be the next step that I should follow to
Okay.
make this bot move. Like those are just now actuating joints which are moved with this teleop key.
Which bot is this are you using?
Means URDF file dot URDF.
Yeah, but what model of robot is it?
I think he custom made it.
Ah, okay.
Yes,
Hmm.
I
Yeah, nice.
done means Fusion 362 URDF modeling,
Hmm.
and
So you carried it and then imported as URDF.
You
yes,
made
yes.
you made your you wrote your own URDF file, or you exported it somehow?
Means I first made a CAD and then I exported from a plugin of your Fusion
Okay.
362 URDF exporter,
Okay.
and
Yeah.
from that
Nice.
uh, I used a plugin of Mechanim will drive, and this is how it works.
Hmm.
So basically, I just use with this Teleopia, and I don't want to do with this. I want to move it actually with the code so that I could implement on a
Yeah. You want
real
to
hardware,
do
real time.
or you want to make it autonomous?
Yes, yes.
Okay. Yeah, I think yeah, that's a good project that you're doing, and I think you can write it on the server, and we can discuss it as well. You can just write, and there would be probably multiple people who can help there as well. So yeah, just maybe share a screenshot and write what you are looking to do, and you can definitely yeah, get guidance there as well.
Okay.
Yeah, and also
And
like since you are doing this project on your own, you can if you are attending these meetups regularly, we have this project accountability section, so you can share your progress weekly. Like this is the thing that I did. Here is what I where I got stuck at, and you can yeah just let others know, and then have a detailed discussion in the server later on.
okay,
Yeah, if that would
no,
help you.
yes. And means sorry, I didn't hear that what you are suggesting about that course ETWH ROS
ETH
course.
Zurich. So you yeah, I'll send it to you. I'll send the link to you. But also in resources channel, you can check. It's already mentioned there. But I'll send it to you after this.
Okay.
Yeah, and
So
yeah.
I was asking that could I have the intro of you guys also, because
Yeah, definitely. Everyone will be doing their intro. So, yeah, so my name is Chandandeep, and I am a master student here at RWTH Aachen in Germany. I'm currently doing my master's thesis, which is along the lines of using reinforcement learning for cloth manipulation using a robot. Uh, and before that I've worked on bin picking using deep learning. So I'm mostly into deep learning, computer vision, and robot manipulation, basically. Yeah, that's from my side. And yeah, I'm also conducting these meetups now regularly from, I think we started in January. So yeah, since it's a month we are doing these meetups.
Okay. So basically, means now in my college, I have to means my project is itself stating that I have to segregate ripened and unripened fruit. So I was like wondering what to do at that instance. So I just means gone through the basics like what is the cost function, activation functions, and
Hmm.
the machine learning, supervised learning, and unsupervising those basics. But what next step should I take to means get things get working? Like I have to suppose apple is the case, and I have to segregate an ripe apple and unripe apple, and that unripe apple would be used further, and I would take its center of xy coordinates and the distance from the camera and the arm, and that unwrapped apple would be picked up and sorted into another basket. So how could I means
Yeah, so
say
basically, yeah, basically, I think this is a more detailed discussion that would take more time, which is not in the scope of the discussion today. But we can
okay,
talk about it on the Discord server. And I think for starting, maybe you should check the Kaggle competitions, and maybe and before that, have you done some machine learning courses and stuff like by Andrew Ng on Coursera
yes,
and
yes.
other things? Yeah. So
Uh, the first one I have did neural networks and deep learning.
yeah, okay,
Mm.
great. Yeah, so you can take up more courses initially because they would also give you some hands-on experience. And after that you can try Kaggle competitions, and you can get like I think they are not that hard. You can take simpler problems in the beginning, but yeah, after that I think for your problem we can specifically discuss on the Discord server. I think that would be better.
Okay.
Yeah, yeah. Yeah, and yeah, Martian, you can introduce yourself. And yeah, yeah. Go ahead.
Yeah, I'm a master student at Avityah, and yeah, like Chandeep, even I am into deep learning and machine learning stuff, and yeah, I've just started my journey into this, which is already a long way path. So yeah, yeah, that's it. Yeah, this.
Yeah, thanks. Thanks, Martian.
Thank you.
Yeah, so guys, also, I know today's meetup was not perfect because my internet got some problem and I was not able to open Discord as well. And that's why we had to shift to Google Meet. And I know it didn't went perfectly, and normally we have more people joining, but we just announced it uh, at the last moment, and that's why I think a lot of people could not join as well. So what are your feedbacks for today? How can we actually improve this thing?
It was a great session, and a lot of presentation were there and deeply explained. So I don't think it hardly any affected on the the quality of the meeting. It was as great as before. So yeah,
But I think yeah, definitely more people would be joining because like 1 or 2 minutes ago, just announcement was made that we are doing it on Google Meet, and yeah, I'm not sure how many people actually saw it.
yeah, and nonetheless, but the quality matters, and the quality was superb.
Okay, thanks. And yeah, and were the explanations clear? Do we want to follow this particular format? I think one disadvantage of this format is that not everyone wants to make presentations, and it's also stressful doing it in 30 minutes. So what do you guys think? Like, be honest. We are just learning here and trying to improve.
So we could give the topics earlier and say to means only present at the meetups.
Yeah, that's but another challenge. Before that, we had this thing. One person would be preparing a project to explain, and that was going really well as well. But it was a problem. It was a challenge to always find a new volunteer for every week who would be making a detailed presentation as well. But maybe we can just keep to these theoretical concepts and yeah, assign presentation roles later. I don't know. Yeah, I'll have to think about it. But overall, like Virendra, you joined for the first time today. So how was your experience? Basically, normally we have definitely more people. The last meetup was actually it went to 3 hours because there were so many presentations.
Okay, means it was nice, and uh, means I also got to learn the concepts also, and everyone was means like putting their efforts and making things understandable.
Okay, perfect. Yeah. So yeah.
So Virender, I was thinking you could ask your other colleagues to join as well. So it would be, I mean, really helpful for the community. You know, I guess it would be really late for you, probably
Yes,
what 2:30 around. But
yes, yes,
yeah, so we can if we see like we have a good quantity or and good number of participants from your side, we can shift the meeting time one day. So yeah, so if it's possible for you, to
Yeah.
ask your colleagues to join.
Yeah, that's a
okay,
very good point that you made actually.
That's a two-way benefit for you and for the community.
okay. I will ask them to do so.
Yeah, we can have an introductory session, probably a career guide as well. So,
Yeah.
I mean, that's just an extra thing, like going beyond the mind. Yeah.
I think next week,
Yes,
what I am thinking of doing is next week we can just have a more casual discussion instead of having to explain some concepts or projects. Just like getting to know each other and yeah, a general talk session. What do you guys think?
yes. Means it would be nice, like to means we can like uh, connect with those with which are similar to means like thinking similar to ourselves and get in touch with them and get to know what their thoughts are on particular topic. It's after the session
Mm-hmm.
gets over.
Yeah, no, normally we do it like after the sessions like we are doing right now. But like I want to dedicate the whole session. Maybe we'll do a shorter one, 30 to 45 minutes or so, and we'll just have like introductions and casual talk and interests and yeah, what our expectations and how we can make it better and stuff like that.
Yes, yes, it would be a nice idea.
Okay. Okay, all right. Now I know it's quite late in India, so yeah, I'll just wind down the meeting now. So thanks a lot, Virendra, for joining. Thanks, Karthik, for joining. And yeah, hopefully see you in the next week as well.
Yes,
Okay,
probably I
perfect.
would be preparing for the test at that time.
Okay, you
I'm
you have
having
your test.
next Sunday.
Okay,
On
okay.
next Sunday, I would.
Mhm.
Yes,
Okay, all right. Then all the best for your test, and
yes,
just you can share the problems that you explained today, your ROS project and other things. And I think that you will get a solution from the members here soon.
yes, yes.
Okay.
Definitely. On which means on which
channel.
thing should I post?
Yeah,
Channel.
so you can post it on general help, or if it's just general guidance related stuff, or you can post it on Ross help. There is a separate channel in the help
Yes,
section.
yes, yes.
Or if you just want to have casual conversation, or just generally want to ask something or talk, just go to chat room and just write anything.
Okay.
Yeah, or you can, yeah, just also message me anytime if you have trouble understanding the server. There are lots of channels, right?
Yes.
Yeah. Okay. Okay, perfect then. Thanks a lot for joining. I hope you
Yes.
enjoyed and had a good time, and also learned a few things. Thanks for your presentation, and thanks a lot for joining. See you next time then.
Yeah, thank you.
Yes.
Thank you for
Thank
the
you.
session.
Thank you. Bye.
Thank you.